Welcome to AlgoGuru, and in this video we are going to take a look at another arrays related problem. The problem we are going to take a look at today is buy and sell stock twice. In the last video we looked at the problem buy and sell stock once. So that is given a range of days and then the prices of the stock for that particular day. We were finding the max profit that can be made by buying at a particular index and selling at another index. And for this example, if we do the same thing, we will get the max profit to be 7 because we can buy at 8 and sell at 15, and that will give us a profit of 7. So this is just doing it once. What if we have to do it twice? We know that when we do it twice, it cannot be overlapping, right? We cannot like buy at 11 and then sell at 14 and then do another one at like 8, buy at 8 and do it 15. We cannot do something like that. It has to be like separate days. So we already know that the max profit is 8 and 15. So the difference is 7. And then we have to find the next best value. What will be that? And for this given test case, it's going to be 9 and 12. So that will give a profit of 3 plus 7. And that's going to make the answer to be 10. So that's the test case that we got. So the next step is look how to solve this problem. It's a two-step process. In the first step, it's the same as what we did the last time around. We will go through the entire price list and then we will find the max profit. And then the trick is that we will find the max profit at each index like we did last time. But we were not saving that. But in this particular case, we will actually save that values. So that is where actually dynamic programming comes into picture. We are going to keep the values from the first iteration and then use that in the second iteration to find the max profit for buying and selling twice. So as I have already explained to you, the first thing that we will need to do is to find the size of the input array, which is called prices over here. And then we actually need something like a result. This is actually not a result. It will just be a result for the first iteration. So this will be like n minus 1. Actually, it will be n. And then we are going to set everything to 0 on this one. And the next step that we are going to do is that we are going to get a min. And so this will be the minimum value. So where are we going to get the minimum value? We are going to get the minimum value using a platform function, which is called numeric limits. And we are going to pass this, and that's going to give us a min value. So this is like a min value that we'll be using at some point to do certain operations. As I get into the meat of the things, you will really understand what I'm talking about. And then we will have something called max profit, which I will set to 0. So this is basically the housekeeping things that we want. And the first step that we are going to do is the first iteration. So that is like starting from I less than n, going all the way I is equal to 0 to I less than n. And at every point of time, what we are going to do is that we are going to find the minimum of min and prices of I. And then we are going to get this max profit. So that will be like max profit and then prices of I, comma, I'm sorry, prices of I minus min. So that is going to give us the max profit, and then we will add that into the resultant. Let's call this like resultant. So that may be like a pretty interesting name to have. So we will just add the max profit to that resultant thing. So for example, at 12 it will be 0, at 11 it will be again 0, at 13 it will be 2, at 9 it will be again 2, at 12 it will be 3, again at 8 it will be 3, and at 14 it will be 6, and again at 13 it will be 6, and at 15 it will be 7. So that's what the resultant array is going to have at the end of this for loop. So that's the first iteration. So the second iteration is going to be something more interesting, because what we are going to do is that we are going to start at the end of the array, that is the prices array, and we are going to keep I greater than 0. So we will not jump into 0. So when I becomes 1, that's pretty much it. We are going to end over there. And what are we going to do it? Here, this is where we are going to use the max. So max, as you see, has been set to min value, right? So this is the trick over here. Max is set to be the minimum value of a double. So we are going to get the max, and then we are going to get the whatever is at that particular index. That's pretty much it. And then we are going to get the max underscore profit is equal to max of max profit, and then what we are going to do is we need this max minus whatever is that prices of so we will just like take like the prices of I plus the resultant I minus 1. So the reason why we are taking a resultant of I minus 1, so we are actually going one index further down. So we are basically eliminating the last index, and that's the reason why we have this condition. Be careful with this. If you put like I greater than or equal to 0, then this is going to break. At this point it will crash. So you don't want that to happen. That's the reason why you have resultant of I minus 1. So that's basically it. So all you have to do is like you just have to like return max profit. And I got this test case already written over here, the same that we got over here. So let's run and see what we are going to get. Alright, so we got this one, like it's 10. The best stock value is 10. Like we said, like okay, it is a difference between 8 and 15 and the difference between 9 and 12. So what if I make this like 14? So then it would be 7 plus 5. So that we should get like 12. Let's see whether we are going to get 12. There you go. We get 12 right over here. So that's pretty much it for this problem. It's a dynamic programming solution. It's a two-step process. The first step, you create a resultant array, and in the next step, you use that resultant array to find the max profit. That's it, guys.